This should be a short and sweet video on making dilutions. Although I noticed on my last slide, before I was clicking out of it, did I spell equipment wrong? Did I get a little excited here? Put a little T. There, let's get that out of there. Equipment. List all the safety equipment so you don't lose one careless little point for not using safety equipment. And the same will go when we do a dilution. Dilutions are also pretty common. You know, often when I order acids, I order the most concentrated form I can get. So my hydrochloric acid comes like 12 molar. I don't need to use 12 molar acid very often, but it's cheaper to buy it that way. So we usually dilute it. We add water to achieve whatever concentration we're looking for. And this is right, that the moles of HCl would stay the same before and after the dilution. The difference is just the volume. The dilution equation's pretty handy. This M1V1 equals M2V2. Now there are other ways of calculating dilutions, but I kind of like this. Although it's not in the AP equation packet, it's something that you'll use relatively often. So you might want to, put this in your long-term memory, at least until the beginning of May. M1V1 are the original molarity and volume of your given solution. So I might be starting with a 12 molar solution of hydrochloric acid. M2V2 are the desired volume and molarity, the conditions of your final solution. And there are a couple different ways that you might use this equation. It's for changing the concentration. Sometimes people will say, I don't know if I'm supposed to use the molarity equation or the dilution equation. Usually with the dilution equation, you already have a solution and you're just changing the molarity. With the molarity equation, you're making the solution. So here I want to know the concentration of a solution prepared by adding 100 milliliters of distilled water to 500 milliliters of a 0.5 molar sulfuric acid solution. So I already have a sulfuric acid solution, and I'm just changing the volume. I'm either adding more water, or I could maybe be evaporating the water, and that would change the concentration. So that's maybe what I'm looking for with this M1V1 equals M2V2. We already have a solution, and we're just changing its concentration by either adding or evaporating water. The original molarity is 0.5 molar. It doesn't matter that it's sulfuric acid. I'm not changing that. And the original volume is 500.0 milliliters. I want to know the new concentration, that's the M2, when I add 100 milliliters of distilled water. So now the final volume becomes 600 milliliters. Now, on the flip side, they could have said something like, hey, you've got this 500 milliliter sample of sulfuric acid. Somebody left the cap off the bottle, and the next day they noticed that the volume had decreased to 450 milliliters. What's the new molarity? So I could have something going in the opposite direction where the final volume goes down. All I have to do is plug this in my calculator. In this case, I've added water, so it should be more dilute. And the molarity goes down to about let's say 417. The original molarity was given in 3 sig figs, so I'll leave 3 in my final molarity. Now let's say again we want to explain how to make a solution, a common question in free response problems. Explain how to prepare 500 milliliters of a 0.5 molar hydrochloric acid solution starting with a 12 molar stock solution. Awesome. Okay, so I know that I have a 12 molar solution to start with. I know what I want. But I don't know how much of that original solution to use. So that's usually where we're going to start out here. We can use our same equation. M2V2. I want to make a dilution. The original molarity is 12 molar. But we don't know the original volume. How much of that should I use? I know what I want, though. I want a final solution that is 0.5 molar. There we go. 0.50 molar. And I know that I want 500, I like this, decimal spot, milliliters. Okay, so this isn't bad. Plug in our calculator. Let's see, volume. The final volume was given in 3 sig figs, so let's leave 3. Let's say V1 is 20.8. And now that 20.8, that's milliliters of 12 molar HCl. Now we should make note of one thing. When you use that molarity equation, molarity equals moles per liter, then your volume does need to be in liters. But not when you're using the dilution equation. As long as the final and initial volumes are the same unit, it's fine to use milliliters. If one of them's liters and you wanted the other one in milliliters, you'd have to do a conversion. But this one, it doesn't matter what your unit is. I like that too. Okay, so we've got this volume, 20.8 milliliters of the original 12 molar stock solution. So here we go. Let's explain how to make the solution. And again, we would look at the list of equipment available. They usually say you have the following equipment in the lab. But it would probably go something like this. I'll remember it this time. Step 1, wear whatever safety equipment they list. Listed. Now, especially since this is a concentrated acid, I would highly recommend wearing goggles, gloves. I mean, if they list an apron, put the apron. I don't always wear the apron or a lab coat or whatever. But any safety equipment listed, put that on first. There's my first step. Step 2. I'm going to measure 20.8 milliliters. And now make sure you specify like 20.8 milliliters of what? Of 12 molar, we'll sneak it in down here, HCl. That's another place where people will make a common mistake. Measure 20.8 milliliters. Awesome. Of what? Oh, that's the original stock solution, the 12 molar solution. Okay, so now here's something specific for acids. And this is kind of important too. For acids. In college, I had this tiny little Southern chemistry professor. Her name was Dr. Tammy Melton. And Tammy always taught us this. Do as you oughta. Put the acid in the water. She'd say, she looked kind of like an adult version of Annie. Like she was kind of short, but she had like this huge head of curly red hair. She was a hoot. And she'd kind of say in this like Southern accent, do as you ought to put the acid in the water. And I remember it today, and it's important. When you dilute acids, the process is exothermic, so it releases a lot of energy. Now, it depends on how much solution you're making, like how much energy is released. But you want to put the acid in the water so that the water can absorb some of that heat. Water has a high heat capacity, so the water will kind of start absorbing that heat. And again, I would kind of do like this picture where I would add the water first. So maybe I'd have like, I don't know, half my container filled with water. So let's say this is water. Then I would add in my solution. So let's say this is the HCl. I would use like a little graduated cylinder or something like that. Let's actually put that down. Using a graduated cylinder. Because again, if they list a whole bunch of lab equipment, they're going to want you to specify what equipment you're using. And so they would want me to say like graduated cylinder rather than beaker. Don't measure 20.8 milliliters in a beaker. Beakers usually don't have as precise markings as a graduated cylinder might. Okay, so I'd probably, maybe fill my container about halfway with water. Then I would add the acid to the water. So in 3, maybe we'd say like add approximately, what are we making here? 500 milliliters. So maybe we'd say 250 milliliters of distilled water. Now this could be a appropriate sized beaker. Or like in this case, a volumetric flask would be totally fine. So I'd fill that maybe about halfway. Then I would add my acid. Do as you oughta. Put the acid in the water. Add the acid to the water. And swirl it around so that, again, the water will absorb the heat. We'll put that down too. Diluting acids is exothermic. And you'll notice it. I mean, even if you're making 500 milliliters, you'll notice like, woo, it's getting hot. Now, if I were making large quantities of acid, then I could run into a problem if I add the acid first and I start adding the water, where like it almost kind of like the water boils, like it sizzles a little bit. So you might be like, oh yeah, I'm adding the right amount of water, but some of that water evaporates because the process is so exothermic. So that's another good reason for putting the acid into the water. Then the water will absorb the heat and you're not going to evaporate a significant amount of water. So I got the acid, some water, I would swirl it around, and then finally, step 4, I would add enough water, distilled water, to make, in this case I want 500 milliliters of solution. Excellent. Now, if this were a base, or if this were like a sodium chloride solution that I want to dilute, then you don't have to worry about the whole like do as you ought to put it in the water. Just for acids, when you dilute an acid, it's exothermic, and that's why we want to put the acid into a larger amount of water, so that it absorbs a little bit of heat. If it's not an acid, it really doesn't matter. Then I would do kind of like in number 3, where I'd have about a half full container of water, and then you can add your solute, whatever it might be, and stir it up to dissolve. But the exact order wouldn't really matter. I mean, then you could start with the original solution. You could add some water. But for acids, do as you oughta. Put the acid in the water.